I am admitting participants.
Voy a compartir mi pantalla. ¿Se ve bien? Perfecto. Y vamos a dar unos 30 segundos antes de partir, así que les pido un poco de paciencia, todavía hay gente uniéndose. Ya, en honor al tiempo, vamos a partir. Hola a todos, primero darle la bienvenida a esta charla. Gracias por participar del evento. Me presento muy brevemente. Mi nombre es Cristóbal Alcázar, soy estudiante del Magíster de Ciencia de Datos de la Universidad de Chile. Además me encuentro participando en el primer programa de embajadores estudiantiles de High Face, que uno de los objetivos es organizar eventos como este. Y el contexto de la charla del día de hoy se encuentra enmarcado dentro del ML, Machine Learning Democratization Tour, que es una iniciativa de High Face lanzada este año y cuyo objetivo principal es difundir y enseñar su ecosistema junto a las herramientas de código abierto para el desarrollo de aplicaciones de ML. La idea es alcanzar a más de 5 millones de personas este año y hasta la fecha ya se han celebrado 34 de estos eventos en diferentes partes del mundo. Así que el día de hoy tenemos la oportunidad de celebrarlo en su primera versión acá en Chile, junto a la Iniciativa de Datos e Inteligencia Artificial IDE, de la Universidad de Chile como anfitrión. Así que les quiero dejar ahora con Felipe Tobar, que es director de la Iniciativa de Datos, que nos contará un poco más sobre la misión de IDE y luego eventualmente continuamos con la charla. Ahí, Felipe, si puedes compartir.
¿Se ve mi
Sí.
¿cierto? ¿Mi presentación?
Sí, se ve.
Ya. Bueno, muchas gracias, Cristóbal. Les quería contar un poco de la iniciativa. La Iniciativa de Datos e Inteligencia Artificial es parte de la Facultad de Ciencias Físicas y Matemáticas de la Universidad de Chile. Y nuestra misión es potenciar y visibilizar todos los esfuerzos de ciencia de datos que se hacen desde la facultad hacia afuera. Entonces, en la línea también con nuestro rol como institución pública, el alcance de la iniciativa puede entenderse en 3 dimensiones, ¿ya? Primero, formación de científicos, ingenieros, ingenieras del futuro, con una fuerte capacidad técnica para implementar y desarrollar herramientas de ciencia de datos e inteligencia artificial. En segundo lugar, ser un lugar de encuentro para investigadores e investigadoras, para ayudarlos a potenciar su colaboración y su producción científica. Y el tercer eje, o sea, tenemos formación, investigación, y el tercer eje es lo que a veces llamamos extensión, que es la comunicación de todas estas herramientas al mundo, ¿ya? Y este es un buen ejemplo de la democratización de los métodos de Machine Learning en este caso. Creemos que es muy relevante, sobre todo desde una institución pública, poder entregar a la sociedad en distintos formatos y en distintas profundidades herramientas que creemos que son súper importantes, tanto científica o académicamente, como para los desarrollos que necesita el país. Si tuviéramos que resumir nuestro objetivo de forma muy concisa, pretendemos ser una plataforma interdisciplinaria, ¿ya?, de generación y gestión del conocimiento en el ámbito de la ciencia de datos y la inteligencia artificial, ¿ya? Y nuestro fin último es generar un impacto positivo en la sociedad. Estas herramientas nosotros creemos que pueden ser transformadoras para mejorar el bienestar social. Entonces, era un muy breve comentario de la iniciativa, me gustaría dejar los invitados a que nos sigan a través de nuestro website, nos manden algún correo si tienen alguna pregunta o si quieren quedar en la lista en la base de datos para que reciban información de nuestros eventos. Nosotros continuamente, y esta información está en la página web, pero continuamente organizamos charlas, tenemos semanalmente o casi semanalmente charlas de investigación donde presentan los académicos de la facultad que hacen trabajos de investigación en ciencia de datos. Tenemos eventos también, hace un par de semanas tuvimos una charla de la subsecretaria de Ciencia, Tecnología, Conocimiento e Innovación, donde hablamos de la política de inteligencia artificial. Y estamos súper entusiasmados en poder involucrar a estudiantes y actores fuera de la facultad también en los proyectos que hacemos acá. O sea, los estudiantes participan, como dijo Cristóbal, a través del Máster de Data Science. Tenemos otros magíster también en la facultad, tenemos programas, tenemos prácticas, somos apoyados por distintos centros también en la facultad donde podemos involucrar a estudiantes que quieran participar en proyectos de Data Science, como el Centro de Modelamiento Matemático, como NIC Chile. Y podemos articular entonces desde la iniciativa participación de ustedes en distintas instancias para que puedan ir aprendiendo cómo hacemos ciencia de datos acá también. Entonces, eso los quería dejar invitados. Por favor, cualquier consulta nos pueden mandar un correo o pueden revisar nuestra página web para ver nuestros futuros eventos. Gracias, Cristóbal.
Perfecto. Y ahora vamos a presentar a nuestro invitado de hoy. Deme un segundo mientras comparto. Ya, la charla hoy día en inglés. Nuestro speaker es Vaibhav Srivastav. So today we are very happy to have here Vaibhav. So a brief view about Vaibhav. He's currently a research student at the Stuttgart University in Germany. His research is in the field of computational linguistics. He's a Hugging Face fellow and is currently working as developer advocate intern in the company, developing tools and building educative content around them with particular focus on speech processing. And he often participates in giving talks like this and leading reading groups. This year, he was one of the organizers and volunteers of the EuroPython conference. So again, thank you very much, Vaibhav. We can get to the talk if you're ready, and feel free to share the screen and start whenever you want.
Perfect. Let me quickly try and share my screen. Oops. Are you able to hear it? Are you able to see it?
Yes.
Okay, perfect. Let me just put this on slideshow. All right. Well, good afternoon, everyone. Thank you so much for joining in. Thanks, Chris, for the opportunity, and thank you, Philippe, for talking about your institute. It's always nice to sort of meet new students, new people, new academics, and try and sort of spread the word of how they can sort of supercharge their machine learning journey with Hugging Face and its ecosystem. So I'm Vaibhav. I go by VB. So at any point throughout this chat, I don't want to say that this is a talk. Let's consider this more as a chat. So throughout this chat, if you have any questions, feel free to just pause me and just ask any questions at all. I want this to be an interactive session, and I want you more than anyone else to sort of understand what exactly is it that the Hugging Face Hub does, and how exactly does it help you in your journey, whether it is in research or it is in terms of job opportunities or in terms of just building up a portfolio in machine learning, or just dabbling around and so on. So typically, let's start from like fundamentals, right? So typically when you start off by in the field of machine learning, you would have some sort of a problem statement, right? Now let's say that your problem statement is that you take in certain article and you have to generate a summary of it, right? So the article could be something like Elon Musk, who is the CEO of Tesla, he tweeted something, and then blah, 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 blah. 10 different paragraphs, and all of this happened, and because of which the stock prices of Tesla went down, right? Let's say that that's an article. Now, what you want to build is you want to build a machine learning model which takes this article, right, and then gives you a one-line summary of that article. So a summary of this article would be Tesla stock plummet as CEO tweets nonsense, right? Now that's your problem statement, right? On the first glance, this looks sort of easy to do. There are multiple ways that you can do it. You can use heuristics, you can use different models and whatnot. But as you start sort of building this, you would realize that the first thing that you need is a data set, right? So you don't just need like one article, you need like thousands of articles. In fact, thousands, not just thousands, you want tens of thousands of articles, right? These articles could be from Washington Post, these could be from New York Times, could be from Spiegel, or could be from your favorite newspaper, right? But fact of the matter is that you need to collect all of this data, then you need to clean this data, because sometimes there would be images in articles, sometimes there would be, bad characters in article which our model may not like, and so on. So you would have to do like quite a lot of iterative process of collecting this data and then cleaning it and then pre-processing it in such a way that your model can consume it, right? Once you have that data set ready, then you go into this another iterative cycle of picking a model, then training a model, evaluating it, how good is this model. So you train the model, meaning like you show the model enough examples, right? You define what sort of loss would this model be trained on, right? What would be the objective of this model? In our case, the objective of the model would be how close the model is, how close the model is to generate like a summary. And then we evaluate, meaning how accurate the model was in terms of its evaluation. We tweak some hyperparameters, and we keep on repeating this till the time we get a model which is good enough, and take that with a grain of salt, which is good enough for the data set that we have. Now, in the last 2 minutes, you would have realized that this entire process can be really, really time consuming, right? Not just time consuming, this also involves a lot of effort, right? Effort, not just in the sense of like you having to run the same thing again and again, you also have to keep track of all your experiments, all the artifacts, all the data sets you use and whatnot. Especially for a beginner, this might become very overwhelming, right? Now, let's try and see if we can sort of, bridge this gap with certain ecosystem tools. Throughout this time, you must be thinking, surely there must be an easier way, right? And what does this easier way sort of look like, right? So first, that you should be able to leverage existing machine learning research out there, be it in terms of research papers, be it in terms of machine learning models, whatnot. You don't want to unnecessarily write code which is already available in the market, so to speak. You want to be able to collaborate. So meaning like if there is someone who's already developing a summarizer for some sort of specific articles, then you would want to collaborate with them and build on their work instead of just reinventing the wheel all the time, right? And second, you would, and like last but not least, you would want this to be open source, right? You would want to be able to share your work with other people, and just be able to just be able to sort of try and experiment things out in the open. And what I've explained so far is quite similar to how GitHub works, right? For those of you who are from computer science background or from engineering background, you might have come across GitHub once or twice, right? This is exactly how GitHub works. You have a code repository, you push some updates over there, then there is an entire community which can then work with you on your specific code base and provide you some updates, provide you some reviews and whatnot. And that's like basically that is what is what Hugging Face does, but for machine learning research and for downstream machine learning tasks. And this is where sort of like Hugging Face at its core comes, right? Like the way sort of Hugging Face helps in all of this is one, by providing architectures and models that are available out in the open source that you can use for your specific machine learning tasks. So this is not just for like text, but like across different modalities. So you can use it for speech, you can use it for images, you can use it for text, you can use it for reinforcement learning, and we'll cover the overall domains that Hugging Face ecosystem covers. But first thing that it provides is models, and there are data sets. So we do have an exhaustive sort of library of data sets that you can, with just like few lines of code, be able to sort of access and use for your projects. And these projects could be like, data analytics projects. These could be these could be data analytics projects. These could also be, sort of more simpler projects. Sorry, more complex projects like trainings, domain specific models, and so on, right? And so this is not just like Hugging Face as a hub is not just used by just researchers or just academics. It's used by firms all across as well for production use cases. For example, we have Google AI on Hugging Face. We have Microsoft, SpeechBrain, Amazon, Alan AI, all sorts of research group, all sorts of sort of state-of-the-art names in the field are there, right? And as I said, these are like, you can solve all pretty much all kinds of problems here. So you can solve problems like with respect to natural language processing. There are speech related problems, image related problems. We also have time series models now. We have protein folding models available on the hub as well. And we're constantly sort of we're constantly going around, and we're constantly innovating around what else can we add at the crux of it. In case you did not know, Hugging Face is a fully open source organization. So all the work that we do is out in the open on GitHub through our ecosystem libraries, or through our research work. You must have heard of models like Bloom and so on. So we, like, all the work that we do, 99.99% work is out in public, and the 0.01% which is not out in public is not out in public is the one that would be out in public soon. So yeah, so just to give like a brief tour of what what in terms of open source does Hugging Face does, is we have certain.
Excuse me, can I ask a little question? Can I ask a short question?
Yeah, sure. Yeah.
So when you said a couple of slides back that all those companies are using Hugging Face, like Google AI, Facebook, and others, maybe I'm too unfamiliar with Hugging Face, but do you mean that they use the system privately for their own needs, or that means that their models are available for everyone to use?
So it means that their models are available for everyone to use. And so in some cases they also use it internally as well. But that's like a separate discussion on it on its own. But the point that I was trying to drive across over there is that Hugging Face Hub in general is now the de facto choice for research groups, for private or public companies to share their research as soon as it's out with the community on the hub, right? So you're able to sort of get access to cutting edge research as it gets released now. Does that answer your question?
Yes, thanks very much. Thank you.
Perfect. Right. So just going back to the overall sort of the open source family within Hugging Face, right? As I said, all the work that we do is open source, right? So the key library that you would have heard like time and again about would be transformers. Transformers, for those of you who are new to the concept of transformers, it's basically a type of neural network architecture which has been known to outperform any and every type of previous architectures in all sorts of fields. So it's basically like currently it is the de facto state of the art in every field that you can think of, be it image, be it audio, be it text, be it whatever. So transformers are kind of like pushing the edge. At first, when Transformers started, it started just with the implementation of BERT. But then like now we have more than 150 different architectures supported within Transformers, and through Hub there are more than 80,000 different models that you can basically use just by very few lines of code, right? Then we have datasets, which is a library that that helps you deal with unstructured data as well as structured data. So you don't have to deal with flat files anymore. You don't have to deal with chunky databases here and there for your research purposes. You can use datasets which are already publicly available on the Hugging Face Hub. You can also upload your own datasets and share it with the community. And you can also use similarly datasets from the community for your projects, right? Then we have Accelerate. Accelerate is more of a production or more of a utility-based library, which helps you train transformer-based models in a multi-GPU, TPU setup, so that it's more optimized. It gets work done significantly faster, and you're able to get to from a data set to training to results in a more accelerated fashion, and so on, right? And then there is Hugging Face Hub, which is just the Python client for Hugging Face Hub, which we'll cover in a sec, which you can use to sort of interact with all the models on Hugging Face Hub. In fact, push your own models, pull models, and data sets, spaces, whatever it is that you want to do on the hub, you can do via the Hugging Face Hub library. And up over here, I spoke about like 80,000 different models and whatnot. This is the models page. This page itself is a bit outdated right now because it says 32,000 models. But if you go on huggingface.co/models today, you would see that we have more than 80,000 models readily available for you to use, right? And not just that, you can basically choose what kind of task do you want the model to perform, right? Do you want the model to perform question answering? Do you want the model to perform summarization, table QA, text generation, and so on? There are like multiple different tasks that you can look at. We also support a variety of libraries. So do you want the model in PyTorch? Do you want the model in TensorFlow? Do you want the model in JAX? And so on and so forth, right? There's also support for choosing which language was the model trained on as well, right? So if you want something which is specific to, say, Spanish, right, then you can choose Spanish in languages and it will show you models specifically for that language. And as you can see over here, some of these models, this is like the figure that they were downloaded for in the last 30 days. So for example, Distill GPT-2, back in 2021 of May, it was downloaded like 26.5 million times, right? So that means that there's actually quite a lot of people who are using models like these, who are leveraging the hub for their downstream applications. So why not you? This is a bit outdated, but this slide should now read something like 80,000 plus public models, more than 25 tasks, more than 25 libraries, and almost near complete sort of alignment in terms of languages as well, right? And let's actually look through how does a model look like. I'm still hoping that you can see this page, so let me zoom in. So let's see. For example, let's go to models, right? Let's look at GPT-2. So in the last sort of 30 days, GPT-2 was downloaded 26 million times, right? That's a really insane number, by the way. So let's look at GPT-2. We have a model card for GPT-2, which basically tells you about what exactly is this model. So you have a model description. You can understand what does this model do. There are some limitations of the model. How do you use this in code, specifically, and how do you use it in PyTorch? How do you use it in TensorFlow? What kind of biases does the model, come with, and certain benchmarks, evaluations, and so on on the model, and also how do you cite this model, right? And without having to play with the without having to download the model, you can actually there is something called hosted inference API, wherein you can just give it so for text generation, you can just give it a prompt, and then it will automatically sort of fill the or like generate text accordingly, right? So like right now I'm just telling it to compute next, and it's just like computing the next token for generating text. And you can see that I haven't really sort of opened any sort of terminal, or I haven't like written any code for it. This is just happening the way it's supposed to happen, right? So it's pretty neat that way. Yeah, then
we have a question on the chat that is very interesting. How can I look, for example, a natural language processing model on Spanish, or maybe in another language? There is an easy way to search.
Yeah. So that's a good question, brilliant question, whoever asked that. So let's go to huggingface.co/models, and as you can see, as I was saying, that we have like now more than 80,000 models. Like we have 88,849 models. Let's go down to languages, and let's search Spanish here. Okay, so I click on Spanish. Let's give it a second, and you can see that 88,000 model list got trimmed down to 9,005, right? Models, and you can use, for example, the first model, which is XLM Roberta base. This model was trained on Spanish data, so you can use this for your specific use case for this language, right? Similarly, I can also search, for example, German, and first I'll have to clear all, and then I go to German, and you can see that we have 716 models. We have T5 small, or XLM Roberta base, again, because that was trained on, it's a multilingual model, so you can use it. And yeah, then I can just go on this. I can click on this particular model, and then I can look at the usage, and how exactly am I supposed to use this model, and then just go about building my downstream applications from there. Does that answer your question, whoever asked that?
No, yes, clear. Thank you.
Okay.
Excuse me, Vaibhav, can I add another question?
Yeah, sure.
I wonder how the whole system makes track of the developer or the author of the model. So say, for example, that you publish a paper with a language model, and then I code your model and I upload it to Hugging Face, and Cristobal does the same, and then you upload your own version. So how does Hugging Face recognize which is the true implementation, and how does that relate to the author of the method?
Right. So oftentimes you would see not just oftentimes, but for each model that is available on the Hugging Face Hub, there is a community tab, right? Wherein you can have discussions, you can have pull requests for these models, and you can have further chats with the authors of the model itself, right? Now, in a scenario wherein say, for example, you create a model and you already release, like when you release the model, you release it with some sort of license, right? So it would be either an MIT license. For example, this model is released under MIT license, or it would be something like CC by SA, CC by NA. There are like multiple different types of models, licenses that you can release under, and based on whatever license license you release on, people can then sort of take your model and build something better with it, or just use it for certain other tasks, or they can fine tune that model, for example, further, and create a more robust model from it, and so on. But at the end of the day, it would still be tracked to the original author, and in case of any any disputes, you can always like go to the community tab and just raise a dispute, or just send an email to us, although that has happened quite rarely, not to my knowledge, but yeah, should that happen, this will be sort of resolved. Bottom line is that as long as your stuff is open source, you always get attribution, just because like the community in itself does not believe in stealing someone's work, so to speak. Does that make sense?
Yes, thanks a lot.
Perfect.
Excuse me.
Mhm.
Do Hugging Face models only have Python compatibility, or could I use, let's say, Node or maybe C#?
That's a good question. So if you want to, say, fine tune the model, right? If you want to fine tune a model, or if you want to like make the model better, basically, if you want to change the domain of the model, train it on a different data set, whatever it may be, then you have to do it in Python, right? However, if you want to use it in an application, say built in React or Node.js, for that we have something called inference API, right? So what you can do is you can basically do API calls to Hugging Face Hub to then get results from whatever it is that you want the results for, right? So you can't really like fine tune or like train models using Node or something like that. For that, I think you'll have to be in Python, and more specifically be well versed with a framework like PyTorch or TensorFlow or JAX or something like that. But for downstream applications wherein you're just trying to infer a model, you can do it using the API, which is here, and just use that.
Okay,
Does
thank
that
you.
answer your question?
Yes,
Okay, perfect.
it does.
Awesome. Okay, maybe we pause on the questions for like 10 minutes, because I just realized that I'm not even done with like half the slides and we're already at a half-minute mark. Okay, where is this? Let's do slideshow. Okay. All right. So as I said, you can do this with your favorite library. You can train models with your favorite libraries. You can do this with Keras, TensorFlow, PyTorch, JAX. There are other library support as well, for example, Flax, and so on. But bottom line is that all the major libraries out there are covered for any sort of task that you can think of. Or in fact, actually, let me correct myself. For majority of tasks that that Hugging Face covers, right? So if we now try and draw parallels with what we were talking about before, wherein like you had to do like so many different things, you had to code up like a model, you had to create a data set, you had to then like run multiple experiments, keep track of what sort of loss did you have, what sort of hyperparameters did you use, and so on. Now our workflow sort of changes, right? Because now we can use Hugging Face ecosystem components to sort of supercharge our machine learning journey, right? So for example, now you can just pick a model from the Hugging Face hub. You can train it using a data set which is on data sets, and you can upload the trained model back into Hugging Face hub for it to be used for other downstream tasks and so on, right? So all of this in just like a couple lines of code, right? So you don't have to sort of go out of your way, but once you sort of set up the boilerplate for your experiments, then it becomes really easy, because then it's just a matter of changing the name of the model, changing the name of the data set, and you just like recreate your experiments, or like replicate rather your experiments. So similar to Models Hub, we have a Datasets Hub, which has I think now upwards of 4,000 or 5,000 data sets, and these data sets again are spread across different tasks. So there would be question answering data sets, there would be image, text data sets for specific tasks like machine translation, sentiment analysis, different languages, and so on, right? And you can use, in fact, any of these data sets for your downstream tasks, right? And you can see like some of these data sets were downloaded almost 1 million times whenever this was taken, and so on. And yeah, so one good thing about the data sets is that it is available in public, right? So oftentimes you would see that research groups would study certain behaviors or certain data sets, and then they would upload it on Hugging Face Hub, and then you can use it for other tasks as well. For example, a data set which is uploaded for machine translation can also be used for something like grammar error correction, right? Or a data set used for sentiment analysis can be used for language modeling, just from like a text standpoint. Similarly, a data set for image classification can be used for image clustering, right? Or it can be, or similarly, data sets for ASR can be used for audio classification, and so on and so forth, right? So there's a lot of scope for reuse across data sets, and we support different dialects, different languages as well. And you can similarly to how I showed for models, you can filter the data sets based on whichever language you have, and whichever language you want to work on for your particular use case. And while this might look really sort of complex, right? Trust me when I say this, you can literally like open up your Python interpreter right now and just type these 2 lines, and you would have the IMDb data set ready to use for you, right? So it's not that it's complicated. It's literally just 2 lines of code, and this supports like data sets in general support querying terabytes of data. In fact, one of the things that we're gonna do in I think coming 2 weeks is we're going to launch like a Whisper fine-tuning sprint, which Whisper is a ASR model. And what we're trying to do is to fine-tune a lot of Whisper models on different languages. And for that, we use a data set called Common Voice. And Common Voice has tens of thousands of hours of audios and text, right? And you should be able to sort of train a model like that in a Colab just because of data sets, because you don't have to keep all the entire data set in your RAM or like in your hard disk. You can just stream data sets and still like fine tune the model. So it works quite all right in that sense. So this was all that you could do with respect to say modeling, right? Now let's go back a bit to our news summarizer problem, right? So we had articles, we had, and we wanted to convert these articles into one-liner summaries, right? So let's assume that we have created this model now, right? So we created this model from the hub, we found a data set, we trained the model. Now what do we do, right? Now what's the next step? We want to package it up in our application, right? Or we want to share this demo with the community. What do we do? And more importantly, why do we do that, right? The reason why you would want to create a demo for your research or for any experiment that you're trying to do is number one, to be able to sort of present it in a format that any and everyone can play with. For example, in this slide, you see an image classifier classifier, right, which uses a transformer model. You upload an image and it automatically tells you what sort of class does it belong to. So in this case, it says it's an American alligator, right? Typically, how this would work without a demo would be that you would have, say, about 10, 20 lines of code. Someone would have to set up like an environment, and then they would have to run those 10, 20 lines of code and then see what the output from the model is, which in often cases would not be as as satisfying as like a sort of chart like this. So what you would want to do specifically for your research is to reduce the cliff that it takes for a person to understand what exactly is your research. That's where demos like these help a lot. Also, this helps in reproducing research quite a lot, right? So, for example, there's a new state of the art model. You have a demo, and then you can share it along with your community on Twitter, on Reddit, wherever it may be, and then they can try and like reproduce it. They can help you identify or like debug failure points in your model, and that just makes your research 100% better, right? In fact, if not more. So that's the reason why you would want to make demos. For those of you who have dabbled in machine learning before, you would know that creating a demo is a huge pain, right? So you start off, you're like, wait, what should I use? I should create a Docker environment. I should create a Flask app, a Fast API app. There should be some JavaScript. There should be some CSS. And it just often results in so much frustration. I have personally spent ages just literally rambling and just like hitting my head against a wall to be like, how do I make a demo, right? That it just really just like gets it really gets to you, right? The old way would be that you train a model, and then you containerize it, you put it in like a Docker container, whatever, you put it on Amazon Web Services, something like that. You use Flask, then you would have some sort of a database, and then you would create some sort of a interface using HTML or whatnot. And what you can see right now already is that this specifically for a beginner might not be that that helpful, right? In fact, this might just overwhelm them, right? Give me just 1 second. Let me just mute my Slack. Okay. Sorry about that. Yeah, long story short, we want to reduce the burden for a newcomer, or in fact for like an advanced researcher, to be able to build demos. That's where Gradio comes in. Gradio is basically like a one-stop shop for you to create an environment for your model, and also to create like an inference along with a nice interactive front end for your model, right? And you can see that this is how Gradio typically looks like, right? So you have like an image input, and over here you upload your image, right? You select what certain parameters from the model, and then the model gives you an output, right? This is for something called face stylization using JojoCan, and next would be news summarizer, wherein you can use you can just give like an example to the or like a URL to the Gradio application. It automatically and then you can have certain bit of scraping code for that particular application, and then it passes the input through the model, and then you get some sort of summary outside, right? So it's pretty neat in that retrospect. So we looked at image, we looked at text. You can also do all sorts of fancy stuff with audio. So you can do stuff like voice authentication, using different models. So Gradio is basically the backbone. You can basically do whatever it is that you want, that you can think of with Gradio. It gives you a flexible enough foundation. You can use any modality, be it text, be it audio, be it images, and it literally just works straight off the bat. So it's pretty cool that way. And you might think that Gradio in general might require quite a lot of might require quite a lot of code to be written and whatnot, but that's actually not the case. You can the classify image model, that like the alligator model that we saw, is literally 5 lines of code. You import Gradio, and then you define an interface. What would be the input? Input would be an image. The output would be labels, and you just launch the application. And then classify image would be a function wherein you would define what exactly is going to happen in classify image, right? So this it is actually like significantly more neater than the other options out there, right? Okay, so now we have built our news summarizer. We have created a demo of it as well. But how do we share it with the community? Do we share like a zip file of our demo? Do we upload our demo on Amazon Web Services or GCP, or how do we go ahead with that, right? This is where another sort of Hugging Face ecosystem tool comes in, which is called Hugging Face Space. So Hugging Face gives you practically unlimited, space, and also free CPU space, so that you can deploy your demos and then just like get a URL which you can share with people. And you can see over here there are quite a lot of spaces already. So there are 5,000-6,000. In fact, I think the numbers more closer to 8,000 or 10,000. I don't remember the exact number, but research communities, academics, enthusiasts, hobbyists, everyone creates demos, and then you can share it with your colleagues, your fellow students, your professors, your researchers, your teachers, whoever you want to, and get feedback from them. In fact, also share those on Twitter or whatever it may be, and just get people to understand that. And when you put the community in your demo, then you would see that a lot of people start using those demos. So this is AnimeGAN, and people on Twitter just like go on these demos, and then they would start playing around with them. They would often report issues with it. They would also use those spaces for a sort of more fine-grained research, like for example, how biased is the model, what sort of tendencies does the model have? Does it have some sort of gender bias? Does it have some sort of language bias, people bias, whatever? And this sort of helps a lot when you have a demo and people can play with. So yeah, so as you can see that we're now at like a turning point, right? And Hugging Face is sort of like poised at a place wherein if you're a software engineer, if you're a machine learning engineer, if you're a student, if you're an academic, if you're a hobbyist, anyone can just like use the platform to, 1, find a data set, 2, find a model, 3, fine-tune that model, or train that model, 4, create a demo of that model, 5, host that model, right? So it's basically like a full stack of services that you can use, all free of cost, right? And then you can share those with whosoever you want to, with your group, with your community, and so on, right? In the interest of time, I'm not going to go through the Gradio demo in itself, because I do want to have some time for question answers in the end, but the slides would be shared with you so you can go with it. It's basically a Colab notebook and you can play around with it. And if you have any questions afterwards, just reach out to me on reach_VB on Twitter, and I'm more than happy to help out. And last but not the least, this is the most recent thing that we announced, which is classrooms, wherein you yourself can create a classroom for your batch or for your particular engineering course, or for your for your university and so on and so forth, right? What this gives you is that you have free infrastructure, resources wherein you can, wherein students, your batchmates can collaborate, can create different applications. We have workspaces wherein you can, wherein you can use the environment to then build or like leverage certain state-of-the-art models. We have a thriving open source community on Discord where we're roughly up to 20,000 people, and and so on. So feel free to check those out. You can create a classroom for free with your email accounts, and just check them out. And we have quite a lot of support as well. So just towards the end, just to like summarize this whole thing, right? Like what you can do on the hub is basically the 5 things, right? You can discover data sets, models, demos, and so on, just to get the lay of the land. Like, for example, what exactly is possible with this machine learning thing, with which everyone keeps talking about. You can share your own demos, models with your classroom, with your community, everything hosted for free. So without a single penny from you. You can centralize data sets. For example, if say you're one of you is part of a class wherein there are certain data sets that you're supposed to use for, say, visualization experiments or for machine learning experiments, and you can just have those in a classroom over there. You can train, fine-tune, experiment with, and like deploy models for free on Hugging Face Hub. You can evaluate models and so on. So it's basically any and everything that you would need specifically from a machine learning standpoint. You have all of that and more on Hugging Face. All the URLs that are presented would be available would be available to you after the session. But yeah, with that, I would say thank you so much for your time, and feel free to ask me any questions.
Thanks, Vivi, for the awesome presentation. A great journey for all the Hugging Face Cube ecosystem. So, and maybe we have time for 1 or 2 questions. If anyone has a question, feel free to turn on the mic and speak, or read it on the chat. So I have a question, Vivi, indeed. Today we have a lot of best practices to guide, for example, data visualization, from using the appropriate color of palettes and some aesthetic for the type of data. But in the case of a Gradio demo or a machine learning demo, what make, in your opinion, a great machine learning demo? What are the main guidelines that, I don't know, there must be in the formula?
Yeah, I mean, I think if you look at any machine learning demo, right? One thing that a demo should not be is complicated, right? A machine learning demo should be as simple as possible. So in fact, if you look at any of the really high powered or like high paced demos, like for example, Stable Diffusion or any of those, you want to abstract thinking from your whosoever would be using your demo to as much as possible, right? You don't want them to think about parameters. You don't want to think you don't want them to think about what to type and what not, right? You want to give them enough visual cues to tell them that, hey, this is where you put a text, this is where you put an image, and this is where you get the output, right? So a good demo would often be something that loads quickly, has no more than 1 or 2 buttons, right? So there's one submit button, and then there's one button just to debug or like something like that, and that's it, and you get like an output. And when you simplify this, then what you do is you let your let whoever is playing around with your demo, you give them an opportunity to then be able to experiment a lot more with them, right? And actually like give you some feedback on it, or just play around with it and so on. So yeah, so just to summarize, keep it simple, keep it to the point, and do not complicate it, and abstract whatever you can from the end user.
Perfect. That was very insightful. Indeed, in the Stable Diffusion app, it's a really powerful model, but something that takes my attention is that it has a biases and content acknowledgement at the end. That is part of a good practice in this kind of model, or maybe in natural language processing model, that there is a huge biases. You can tell me a little about that. Thank you.
I think that's something which pretty much all models suffer from, right? There's like this really known saying in the statistical machine learning world, which is garbage in, garbage out, right? So your model would be as good as whatever it is that it has seen, right? Now, if you there are some beautiful parts to our internet, right? For example, there are some really nice communities, like for example, Goodreads, which is a community for books, is a really fantastic community. At the same time, you have places like Reddit or 4chan, which are, like, I don't even have to explain how satirical can they get, or like how sad of a place can they get. Now, when you train a model, you train a model on everything, right? Which means the good, the bad, the ugly, everything becomes a part of that model, right? Not much can be done about that unless you do like really good filtering, but even then, like, there would be biases in the model. I feel like the thing to spend more sort of effort on is how exactly do you build systems which work around these biases, right? So for example, if your model is biased towards a figure, then can you nudge the model to overweight that particular gender, which is being which is being downvoted by the model, right? So those kind of tools or those kind of research help a lot more than saying that this data set is crap. But yeah, that's just my 2 cents on that. I think Felipe had a question, or has a question.
Yes, I have 2 questions. The first one, well, first of all, thanks for the talk and the explanation. Very interesting. I was wondering, because what you showed is all the state-of-the-art models that the researchers code themselves and publish. Then they recycle that code that at some point was experimental while they were writing the paper, and then they put it in a condition, in a shareable condition, so to speak. But I was wondering if I go to Hugging Face, export a couple of models to try whatever I need to do in my data science project. But in a larger project, you would also need modules that compute more basic stuff. So for example, visualization, linear regressions, I don't know, wavelets, things like that. And those things are by now classic methods, which I might implement using, for example, scikit-learn. So I was wondering if Hugging Face gives you like a broad range of algorithms from classic to state-of-the-art, or I only need to go to Hugging Face for the new ones, and then I need to load another library for the classic ones, and so on.
Right. So that's a brilliant question. The answer is slightly complex. So we oftentimes, like, majority of the models on the Hugging Face hub are the most sort of state-of-the-art ones, right? But we do have like another like library in the works. It's called skops, which connects scikit-learn with Hugging Face hub. It now works, so you can use your scikit-learn models and you can basically directly push them into skops, into Hugging Face hub, just through your entire sort of scikit-learn pipeline. I just want to be like really clear here that like Hugging Face never ever wants to sort of be in competition with anyone. Like, we believe that everyone should exist, and in fact, like, we have our own niche. Scikit-learn has its own niche, and we believe in collaboration rather than just replicating stuff that is already at a very good level, right? So that's why we have collaborations. We have collaborations with pretty much all major libraries out there. So there's scikit-learn, there's for like audio, there are specific like ESP.NET, SpeechBrain, and for text, Flare, and so on. So we have like collaborations with them, and it works quite all right. So yeah.
Great. So there's no because okay, I'm maybe in comparison with the rest of the attendees, I'm a little bit old here. So I remember when I was a student, there was an ancient language called MATLAB, and all the modules in MATLAB took a long time to reach the hub at that moment, which was the MATLAB repository, and that was because MathWorks, which was a company that produced MATLAB, had an army of programmers that programmed all the methods. But in Hugging Face, that is not the case. You don't take the responsibility for coding popular methods and put it in the hub. It's the same authors that put their methods.
So actually, it's a bit of both. We do have a very strong open source team, and we have a team working across modalities. So we have 3-4 open source engineers working across for each modalities, in fact, more, who work with these research groups to port these models into, Hugging Face or like transformers. For example, Whisper, the ASR model by OpenAI, that was ported into transformers by Arthur. He is an intern here, and also worked by Sanchit, who leads speech stuff. Similarly, like we have diffusers, which is the diffusion library, and Patrick and Anton and Suraj, all of these guys, they worked with stability AI folks to then port it into diffusers, right? So it's not that the onus is on the researchers. If the research is promising and if there is support from the research group, then we ourselves put in the time to get that model integrated into transformers or diffusers or whichever library it may be. And all of these folks work full time on enriching the library and adding more features constantly.
I see. I understand. Thanks.
Okay. Apparently there is no more questions, and we are running out of time. But if you have any question about the talk, you can email me, and I can do my best to answer. And also remember to follow BB on Twitter. This is the hashtag, the profile. And here's my email. And finally, a little announcement relative to Gradio and Hugging Face. I guess that I will do in Spanish, but it's a machine learning demo competition, BB, that we want to organize here. Queremos adelantarle en el fondo a todos, a los estudiantes, que hay un grupo de estudiantes y profesores en conjunto con la Iniciativa de Datos y con Hugging Face de sponsor. Estamos organizando el Machine Learning Demo Challenge. Se vienen novedades, así que va a ser una muy buena oportunidad para poder poner en práctica algunas de las cosas que Vivi habló. Y eso, o sea, sigan la página de Lidia y manténganse atentos a las novedades. Así que eso. And thanks again, Vivi, and everyone for joining. Thank you very much. This talk is recorded, so we will be uploaded and diffuse for social networks.
Brilliant. Thank you so much, and I hope you all have a great day.
Nice.
Thanks, Vivi. Thanks a lot. We see the sun has set on your side, so
yeah, it's dark. Yeah. No, all chill. Thank you so much. All right, you have a great one. Bye-bye.
Okay. Thanks a lot. Bye-bye.
Thanks. Bye-bye. Thank you, everyone.
Thanks. Thank you. Bye.